So let's do this problem which is based on Kirchoff's law. Okay, and here you have been given a circuit, okay, A, B, C, D, and you're asked to find what is the current in each of these three branches, I1, I2, and I3. Okay, so you're asked to find what is the value of I1, I2, and I3. So this is your I1, this is your I2, and this is your I3. Okay, so you're asked to find what is the value of I1, I2, and I3. So that is the current in these three branches. Okay, so let us redraw this, and here you're also given the values. You're also given the values of these EMFs. So EMF E1 battery, the EMF of the battery E1 is 1 volt, E2 is 2 volt, E3 is 3 volt. The internal resistance of E1, R1, and also R4 is equal to 1 ohms. Okay, and then the value of R2 is given as 0.5 ohm, and R3, internal resistance of E3, that is R3 and R5, both are 1/3 ohms. Okay, so I'm going to redraw this. Okay, so when I redraw this, how will be the circuit? So your circuit is, this is your circuit, and here it has an internal resistance. Okay, so here again you have the another resistance here, and here again you have the resistance, one more resistance, and here you have the battery, another battery. Okay, so you have another battery here, and that battery is E3. And one more resistance is there here, right? So you have one more resistance. So here you are given with one more resistance. So this is your E3, this is your R3, this is your E1, this is your R1, and one more cell is given to you here. This is your cell and its internal resistances. This is your cell. Okay, so this is your E2 and this is your R2, and this is your R4 and this is R5, and the currents are given to you. This current here is I1, this current here is I2, which is going from here, I2. Okay. So the current here is I2, and here the current is I3. So I3 is coming here. Okay, so now you can see here that this by applying the Kirchoff's first rule. Okay, so by using Kirchoff's first rule, from Kirchoff's first rule. Okay, so from Kirchoff's first rule, or junction rule, you will get the relation I1 is entering the junction, I3 is entering the junction. So I1 plus I3 is equal to I2. Isn't it? This I1 plus I3 is equal to I2. So this one relation you have for from by using Kirchoff's junction rule, you have I1 plus I3 is equal to I2. Okay, Now we can use the loop rule. Okay, so loop rule, there are two loops here. This is A, B, C, and this is A, D, C. Two loops are there. All right, so if you take the loop A, B, C, loop A, B, C, if you take loop A, B, C, so we can use the Kirchoff's we can use our sign convention. Using Kirchoff's second rule, our sign convention, we take our direction to be anti-clockwise. Okay, so we can see here that E1 is starting from positive. If you go anti-clockwise, E1 is starting from positive and ending on negative, which is the natural direction of current. So you can take E1 as positive. E1 is positive, and then E2, there is another EMF, which is, if we go anti-clockwise, it is starting from negative and ending on positive, which is not the natural direction of current. So it is minus E2. That is equal to the current through R1 is in our direction. So I1 R1. Then current through R4 is also in our direction. So I1 R4. Okay, and current through R2 is also in our direction. So plus I2 R2. Okay, so you know the values of EMF. Here the values of EMF are given to you. So EMF E1 is 1 volt, E2 is 2 volt. Okay, and the values of R1, R2 and R3 are given to you, right? So if you substitute these values here, what you get? E1 is given as 1 volt. So 1 minus E2 is given as 2 volt. Okay, so when you substitute E2 is given as 2 volt, that is equal to I1 into R1. R1 is 1 volt, so that is I1 into 1, and IR4 is given as 1 volt, 1 ohm, sorry. R4 is given as 1 ohm, so 1 into I1, so plus again I1, and R2 is given as 0.5, so plus 0.5 into R2, I2, 0.5 into I2. Okay, so when you solve this, you will get minus 1 is equal to 2I1 plus 0.5 I2. You will get this relation. Okay, so this is our equation. So if I bring it into remove this 0.5, I can write this as 4I1 plus I2 is equal to minus 2. Okay, so 4I1 plus I2 is equal to minus 2. This is our equation. You are getting 4I1 plus I2, but you already know that I2 can be written as I1 plus I3, isn't it? By using the Kirchoff's first rule, you can see here I1 is entering, I2 is leaving, and I3 is also entering. Okay, so by using Kirchoff's second rule, first rule, you can write I1 plus I3 is equal to I2. So this is from Kirchoff's first rule or junction rule. So you can substitute the value of I2. So you will get 4I1 plus I1 plus I3 is equal to minus 2. So 4I1 plus I1 will become 5I1. Okay, plus 5I1 plus I3 is equal to minus 2. So 5I1 plus I3 is equal to minus 2. Let this be equation number 1. Okay, so you got one equation from the first loop. From one loop you got the equation. Now if you take the second loop here, you can see here our direction is anti-clockwise, isn't it? Second loop, if you see the second loop here also, I'm going to take our direction as anti-clockwise. So in this case, if you see here, E2 is, if you take anti-clockwise, is starting from positive and ending on negative. So it is, which is a natural direction of current. So E2 is positive. Okay. So I'm going to take E2 as positive. E2 is positive. Now what about E3? E3, if you see, I'm going anti-clockwise, so E3 is going from negative to positive, which is not the natural direction of current. So I will take minus E3. Then what is the direction of potential drops? If you calculate in R2, current is not in my direction, it is in opposite direction. R5 also, it is opposite to my direction. R3 also, it is opposite to my direction. So minus I2 R2. So our direction is anti-clockwise, and the potential drop in this I2 R2 is opposite to my direction. Current is flowing opposite to my direction. So in all these R2, R5 and R3, the potential drops are the direction of current is opposite to my direction. So it will be minus. So it will be minus I2 R2. Okay, minus I2 R2. Then what are the other currents? R5 and R3. So minus I3 R5 minus I3 R5 is there and R3 is there, right? So minus I3 R3. So if you substitute the values of this these values, if I substitute, what is the value of E1? E1 is given as 1 volt, isn't it? So 1 minus E3. What is the value of E3? That is 3. So 1 minus 3 is equal to minus I2 into R2. What is R2? R2 is 0.5. 0.5, which you can write as 1 by 2, isn't it? 0.5 you can write as 1 by 2. So I can write I2 into 1 by 2 minus I3 into R5. What is R5? R5 is 1 by 3 into 1 by 3 minus I3 into R3. What is R3 value? The value of R3 is 1 by 3. R3 is also 1 by 3. R5 is also 1 by 3, isn't it? So when you solve this, you will get, what is the relation you will get? You will get minus E2 is given as, what's the value of E2? E2 is 2 volt, sorry. So this is 2 volt. Here it is 2 volt. Okay, so 2 minus 3. 2 minus 3. What is 2 minus 3? Which is minus 1 is equal to minus 1 by 2 into I2, okay, minus 1 by 3 into I3, 1 by, so I can write this as minus 2 by 3 into I3. Okay, and I2 I can write as I2, I can write as I1 plus I3. I2 I can write as I1 plus I3. So when you solve this, when you substitute these values here, I1 and I3, and solve this, you will get the relation, that is 3I1 plus 7I3 is equal to 6. 3I1 plus 7I3 is equal to 6. This is our equation number 2. Okay. So this is our equation number 2. So equation number 1, what is our equation number 1? So if I take the equation number 1 here, equation number 1 is 5I1 plus I3 is equal to minus 2. Okay. And equation number 2 is 3I1 plus 7I3 is equal to 6. Okay. So if I write these two, rewrite these two equations once again. So when I write these two equations, what do I get? The first equation is 5I1 plus I3 is equal to minus 2. Okay, first equation. And second equation is what? 3I1 plus 7I3 is equal to 6. Isn't it? So what I'm going to do is I'm going to multiply the first equation with 7. First equation I'm going to multiply with 7. So it will become 35I1 plus 7I3 is equal to minus 14. And second equation is 3I1 plus 7I3 is equal to 6. So when you subtract these two equations, what do I get? If you subtract, you will get 32I1 is equal to minus 20, which gives you the final answer. Final solution is I1 is equal to minus 5 by 8 ampere. So the current I1 is how much? Minus 5 by 8 ampere. Right? Now I can I got the value of I1. Now this I1 I can substitute in our first equation, right? I can substitute this I1 here in our first equation, that is 5I1 plus I3. 5I1 plus I3 is equal to minus 2. We got the equation of I1, we got as minus 5 by 8. Okay, so 5I1 plus I3 is equal to minus 2. You got I1 as minus 5 by 8. So minus 25 by 8, if you substitute minus 25 by 8 plus I3 is equal to minus 2. So you get I3 as, what do you get? I3, you will get 25 by 8 minus 2. 25 minus 16 is 9 by 8. So you get I3 is equal to 9 by 8 ampere. I3 is equal to 9 by 8 ampere. Right? So I3, you got I3, you got I1, right? I3 you got, I1 you got. And what is I2? So I1 is equal to minus 5 by 8 ampere. I3 is equal to 9 by 8 ampere. So you have to find out I2, which is equal to I1 plus I3. So when you add, you will get I2 is equal to 1 by 2 ampere. Okay, so in this way we found out what is the currents in this three branches. Okay, I1, I2 and I3, all the three branches. We got the current in all the three branches. How much is the current? We found out the value of current I1, I2 and I3. How much is the value? So the value of the currents are I1 is equal to minus 5 by 8 ampere, I2 is equal to 1 by 2 ampere, and I3 is equal to 9 by 8 ampere.